map and now it's your motivation because it's in map sort of thing. So if you're one of those people that didn't quite, I cut myself. You guys ever find a cut that came out of nowhere and you're like, what?
I hurt myself.
It's like, what was sharp? It's like a cat came out of nowhere and was like, ah. All right, well, that's painful.
I put myself on a watermelon.
Yeah.
Out of nowhere.
So, all right, sorry for the moment of loss of attention. But I have no idea what I was saying. Oh, catch up on your work, please. If you did not get... No, that's like I haven't put it on map. I don't like having to use map as the whip. If you've ever heard like whip versus carrot, the carrot is I should do my work because I want to do my work because, yeah, I want to be smart. The whip is like, you didn't do your work. You're bad. Go check con. Yeah, go check con. So a couple of you have work that was due in March, which wasn't that long ago, but that isn't done yet, right? And then there's the new stuff in April that, yes, some of it was due yesterday. Be mad at me if you want, whatever. That did not mean do work on Easter. Huh? I have to. What do you mean it isn't? I'll do it for you. I don't care, but no, yeah, you're good now. I don't know why it wouldn't auto approve. Maybe somebody changed the settings in there. Dependent probability is like, what is the probability that you get the thing that you want after somebody else already took one of the things that you want? And as a human, we know that like, oh crap, if there's a limited supply of things and somebody already took a thing that I wanted, now there's less of them. Or if I'm watching people take their random draws and they didn't get the thing that I want, my chances go up, right? So imagine this situation for me. Ignore your notes for a second. So there, back in the olden days of like theme parks and before cell phones, there were all these little electronics that you could win that like now your cell phone serves a purpose of, like a little portable car television. No joke. So we are at SeaWorld. I want to say SeaWorld. Six Flags? I don't know. Some place with animals that swim. And we're playing one of these games where there's little balls that have like a mystery thing inside of them. So you have to first get one of the balls. Then you have to see what's in it. And you know that there's like one is the TV. One is like $10 cash, right? One is... And my brother, my sister, and I are all like playing this game. So every time we don't win the TV and they keep that thing out, the chances of us winning the TV go up. But if they put the ball that wasn't the TV back into the game, my chances stay exactly the same, right? So dependent probability is when the next thing that happens is impacted by the thing that already happened. What else do we call this? We've talked about situations with replacement, and now this is without replacement. So, my example that I have up here for you guys, jar containing 4 red marbles, 4 green marbles, and 5 blue marbles. If we choose marble and then another marble without putting the first one back in the jar, our second choice is impacted. Here's the trap door, though. Not only will the numerator probably potentially change, but the denominator changes. And that's what people forget to do. So guys, I'm telling you, the trap door is that the denominator also changes. So I wanted you guys to see one of these done out. So let's say, what is the probability that the first marble will be blue, and then the second one will be green? Okay, well, first one is blue. How many blue marbles? Okay, 5. How many total marbles? Yeah, 13. Let's do some addition this morning. Amar, pull your mask up, man. So our first probability is 5/13, right? 5/13. But since we already took a marble out, now there are only 12 marbles left. And now the thing that we want to have happen is green. So we look at 4 green marbles. Our next probability is 4/12, and we have to do that multiplication. Yes. Thank you for reminding me. You are back officially. So take a moment, try these situations on your own, because we just want to check answers and then take questions. We're like, wait, that's not the answer that I got. What are the probabilities that y'all are secretly robots? You done with these more? So the first fraction you're setting up is fairly straightforward. The second one is probably impacted by the first result. Katie Ann? No, yeah, do as many as you can. So we've got 3 here on the front, and then there's more on the back. We don't need to move super fast for the rest of the year. So there will be a lot of time where, like, I give you like 5 minutes or whatever to just try on your own. Do as much as you can. Yeah, push yourself to try to do as many of these as you can. Secret robots. I think Alina's secretly a robot. That's why she's always dancing. That's actually how she charges up her battery. She has to spin.
That'd be some pretty cool technology.
Would be sweet. And if you made secret robots, why would you send them to school? Did you say science? Oh, spying.
Espionage.
Is there that much to spy on?
Absolutely. You can always spy on something.
Then I know Phoenix is pretty cool, but I don't have random cards for you guys. I don't know why. Cards to, like, call on you guys. I normally just kind of pop around the room. So in our first problem here, we're talking about soccer and the students who like to play soccer. Be careful that you read carefully. Be careful that you read carefully, because, like, down here it's neither. This one doesn't ask about being robots. This asks about being not robots. Yeah.
So, at least, well, this one works for this problem, but because it's like a 2/6 chance to not initially choose one student.
Ooh, you're jumping down to the robots, okay?
Yeah. Can you simplify that before multiplying with the 1/6?
Is it? Let's test it, right? If we want to ask the question, let's figure out how we answer the question for, when you guys move on beyond me, because in a month, our time together is pretty much done. So, 2/6 times, what would the second fraction be? What would this? 1/5, because there are 5 students left, and there's 1 non-robot left. So this comes out to be 2 times 1, 2, 6 times 5, 2/30ths, right? Yeah? If we reduced it, I could say or versus or whatever, there's a 1/3 chance first and then a 1/5 chance. Oh, what do we get there? Is that the same? Oh, that makes sense. Because remember, reducing fractions is just taking away a common multiple from the numerator and denominator, which is what we end up doing at the end. Right? When we get our end fraction of 2/30ths, we want to reduce that down. So make sure that we change the numerator and that we change the denominator here. Back up here in the soccer question, what would our second fraction up here be? 4/9. So we get If we don't reduce, we get 20/90ths, or I guess 2/9. Thank you for asking. So if there were 5 students who play soccer, there are also 5 students who don't, right? There are 10 total students. So Mark, in the first event, right, we call each thing that happens, the teacher picks someone who plays soccer, 5 out of 10 people. But that person has been picked. They're gone. So now, how many soccer players are left? 4. How many total people are left? 9. Because we already removed the one soccer player. Down here, same reason, Amar. Down here with 2/6 and then 1/5, we have 2 non-robots out of a total of 6 students. We take one of them away. So now we have 1 non-robot and 5 total students. Does that make sense? Yeah. Is 91? No, I think, 3? No, not 3. 7? 70, yeah, because 70 plus 21, yeah. Why does the next one come out to have a denominator of 91? All right, so my first probability here was green. There were 4 green and 13 total. Amar, you know I'm going to pick on you now. Our second probability here wants to be red. How many red balls are there still? Did we take any of them away? So hold on. Did the first selection being green, did that impact the red? No. So my red now still have 6, right? There are still 6 red. How many total are there now? 12, because they took 1 green away. Some big numbers here. Uh, 144 plus 12 more, 156. Okay, fine. You guys are smarter than me. So you're arguing this reduces out to be 4/26 or 2/13. Questions on the front. Dependent probability. So I want you to take a moment. Captain Jessica, in the HMS Crimson Lynx. Still can't hear you, sorry. Does it matter? Does what matter? The Crimson Lynx? Of course it matters. Maybe not to you. But if I'm going to go plunder a village and steal some booty, I need a ship to get away on. Call up Captain Jess, and there we go. I know, the village is a bad village. We're plundering bad villages. Look, the Dread Pirate, he's bad. The Dread Pirate is bad. Because his band is merciless. Well, first off, play on words. What if this is like a bunch of musicians, right? Band of. All right. So if her ship hasn't already been hit, this will probably be easier to read if we just do this. If her ship hasn't already been hit, Captain Jess has a probability of 2/5 of hitting the pirate ship. If her ship has been hit, Captain Jess will always miss. Oh, well, that's sad. If his ship hasn't already been hit, Dread Pirate Ishan has 3/8 probability of hitting the captain's ship. If his ship has been hit, Dread Pirate will always miss. Ooh. If the captain and the pirate each shoot once, the captain shoots first. What is the probability that the captain misses the pirate ship, but the pirate hits? Okay, we got to take this a situation at a time.
So basically, if so the captain shoots first, so you would do the captain's probability of missing, which is 3/5, and then you multiply it by.
Hold on, slow down. All right, so you said the first thing we do is the captain missing, which is 3/5 because the probability of hitting is 2/5. Right, so our first probability here is 3/5 because that's the captain missing. Now, if the captain misses, is the pirate's ship impacted? No. Go ahead.
You would use like 3/8, and you multiply it by 3/8 because the pirate hits the captain's ship.
Yeah, so then the second event that we want is a non-impacted. So this is still dependent, even though nothing changed, because that is what we're depending on, is did something change or not. So like literally we're dependent on the fact that the shot missed, and or we would be dependent on if the shot hit. So we are dependent, even though it didn't change. You're right, so we multiply by 3/8. And we get 9/40. I do not know if that is reducible. I don't think so. Take a moment if you haven't finished these problems. Try those two in the middle, and then there's one more pirate problem for your pleasure. I will take volunteers to talk us through these problems here in a couple minutes. Just
I have a quick question.
yes.
Why are they avoiding each other? Also, they have
The sea is really small. I mean, the sea just doesn't have enough space. They have to fight each other.
Okay, I have a question. How bad are these conditions? Because you can only, like, are we talking about a cannon?
Have you ever fired a cannon? It's hard to get accuracy.
You know,
It's a massive ship.
what time period are we talking about?
Like right now. Like yesterday.
They don't have cannons. They have
Oh, yeah, we do.
missiles. Missiles, not cannons. Missiles are
We still have cannons. Literally, in my hometown, they still fire off a cannon every time there's a touchdown during the football game. You can roll your eyes, but it doesn't make it not true.
Well, they don't use cannonballs.
That,
They use the
you ever been to Appalachia?
Oh,
I guarantee they do have cannonballs that match their
They don't use it
cannon. They actually fire it towards the river, so they might fire cannonballs. Who knows? They are crazy rednecks. So,
We'll be using it this war between
all right,
Navy ships.
all right, bring it back. We're going way too in the weeds about cannons, and I know, but it's like, does it have a rifled barrel? Is the yeah? And then I wouldn't be a ball.
I don't know, just a triangular prism cannonball. It would not work very well.
You would have to have a what's the thing that goes around it to make it seal the barrel?
It has to.
You know what I'm talking about, though, right? Because Mythbusters uses it, like when they're trying to launch stuff. So does Smarter Every Day. What is the probability of the teacher choosing a student that has done their homework? Yeah, I feel kind of like this some days. What's the probability of the teacher choosing someone who did their homework? 3/8. And then after they've chosen that person, lovely, wonderful student, the next probability of choosing another student who's done their homework, 2/7. Be careful, that denominator changes. And we get 6 56ths or 3/28. If we choose a jelly bean, then another jelly bean without putting the first one back in the bag, what is the probability that the first jelly bean will be green and the second will be red? Our first probability here would be 4/7. 4/14 or 2/7. I like kind of writing down what the probability actually is and then writing down the reduced form. What about red? Ooh, 6 did not change, but the denominator did. 12. Is this where you got 91?
Yeah.
So wait, you mean when you multiply these two numbers, you then asked me if this was prime? You mean the result of a multiplication? You asked if this is prime? Do we see the fault in our reasoning about is this number a prime number? So yeah, 12 91sts, not a prime number, but I don't know that this reduces. All right, our probabilities got better / worse, I think. Not better and better, right?
Why is it the same ship?
Oh, well, if you swoop onto a ship on a rope and just say, like, "Rah!" You can take somebody's ship, and now it's your ship. You just, push them overboard. So, Captain Ben now has the HMS Crimson Lynx.
Maybe he got promoted. And
She retired. Yeah, it was a good ceremony.
There's lots of other things that could happen.
Pirate retirement is pretty uncommon, though. Most of the time they have been in a duel before then. He retires? Yeah, I just haven't seen it in a long time. Yeah. Oh, yeah. So he's not the same guy. Yeah, I remember what you're talking about. But this, it's not the same name. It's just the same ship. So. So the British can't be pirates?
What are we talking about? Are we talking about the Crimson Lynx or the pirate ship?
I have no idea now.
I'm so confused.
I'm rolling. This is what happens in springtime.
Crimson Lynx is Royal Navy ship.
If the captain and the pirate ship each shoot once and the pirate shoots first, what is the probability that the pirate hits the captain's ship, but the captain misses? So, the pirate hitting the captain's ship. 1/3. All right, our first probability here, 1/3. She's charging up her batteries, ladies and gentlemen. Times, but the captain misses.
That's just one.
That's 1 because it has been impacted. Get it? The ship was impacted by the cannonball. So there's a 1/3 chance that event series will happen.
Would Pirate Lewis also be called captain? I mean, maybe
So pirate ships have a different system of governance.
No,
There's-
Captain Hook.
Well,
Captain Greg.
I think that was just his first name. Hook. Well, again, I think that's just his first name. Jack is his middle name, so it's Cap. If you want your child to become a pirate, you name them Captain. Right? So when I have my first child, I might be like, I'm gonna name him Captain because one day he'll be a pirate. So I'll name him Captain Joseph Hudson or something like that. And he's a pirate. No? Look, not all pirates are bad.
You're right. Put one on. That is kind of safe. This is not good.
How does a cannon work? I don't know. So, seriously, that's everything we need to do today. And I'm not trying to rush us through the material because we've gone at a good pace this year. So, get out a Chromebook if you're behind on your con. Get out whatever you want to get out. If you're caught up on your con, this is your time to choose what you want to do.